Today, we are going to cover an easy LeetCode question named valid parentheses. In this question, you are given a string that is composed of three types of brackets: the round brackets, the curly brackets, and the square brackets. And your task is to decide whether the given string is valid or not. An input string is considered valid if all the open brackets are closed by the same type of brackets, and they are closed in the correct order. On top of that, every closed bracket needs to have a corresponding open bracket of the same type. The only constraint is that there are at most 10 to the 4th characters in the given string. Now let's try to solve this problem together. Even though this is an easy question and its solution might be pretty straightforward to many more experienced coders, I still want to spend some time here sharing my thinking process, which could be helpful when one starts to work on more difficult problems. Let's first think about what the invalid cases look like. I can actually think of three different invalid cases. I might see a left bracket, but there's no corresponding right bracket, right? Or the opposite, I can see a right bracket, but there's no corresponding left bracket. And lastly, I might see multiple pairs of brackets, but then kind of intersect each other, right? There are three different cases here. Now let's move on and see how we can identify those cases. Assuming that I'm given a string here, and I would like to scan the string from left to the right. For the first character, there'll be two cases. It's either a right bracket or a left bracket, right? When I see a right bracket, I already know that this is invalid because there's no corresponding left bracket. However, when I see a left bracket, I actually don't know because I might have a corresponding right bracket later on, or I might not have one, right? What I can do is I will start monitoring this left bracket. For example, put it into some data structure, and later on, we'll check if there's a match right bracket for this one. All right, once I put it into a data structure, I'll just move on and check the next character. For the next character, there are actually four cases here. The first case is that we're actually at the end of the string, so there's nothing else I can check. When that happens, of course, it is invalid because there's an unclosed left bracket. For a second case, I might actually see the corresponding right bracket. In this case, it's a good sign, right? Because we find a pair of brackets. When that happens, I know this right bracket is going to match the left bracket, so I don't need to monitor this left bracket anymore. I would like to remove the left bracket from the data structure. There could be also different types of right brackets waiting for us. We might see a right square bracket or a right curly bracket. When that happens, we know this is invalid because for those right brackets, they cannot find the corresponding left bracket in the correct order. And lastly, we might see more left brackets. It could be a round one, or a square one, or a curly one. When that happens, that's basically the exact same case we're dealing with right now. This is like a recursive problem. So it's recursive, and we don't know what we should do now. We will look the next character and following the same process. Now, we'll keep doing this until the very last character of the string is visited. And after that, we'll basically check if there's any remaining left bracket left. If there are still left brackets in the data structure we use, then basically it means that those left brackets do not have the corresponding right brackets, so the given string is invalid. That's the last check we need to have here. All right, I hope the breakdowns make sense to you. And now let's move on to the code implementation part. From the previous solution derivations, we learned a few things. First of all, we need to keep track of the open brackets with a data structure which supports appending new open brackets at the end and also removing open brackets that are just matched by closed brackets from the end. I'm going to code this st. It is default to an empty stack. I also need to have a Boolean variable here and default it to true. Whenever we see any invalid patterns, we'll flip this to false. After that, we need to iterate through the whole string and visit each character. Now, a character could be an open bracket, or it could be a closed round bracket. It could be a closed square bracket. It could be a closed curly bracket. Right? Eventually, this is our open bracket cases. If it's a closed round bracket, what should we do? I will first check if the stack is empty. If it's not empty and the last bracket in this stack equals to the round open bracket, then I would like to pop it out, right? Because it's already matched, so we can just pop it out. Otherwise, I know that this is an invalid string. I will basically repeat this logic for all the closed brackets. The only different thing is that the check will be slightly different. This is a square bracket, this is a curly bracket. Now, how about the open brackets? When we see any open bracket, we don't know whether there will be a corresponding right bracket. The only thing we can do is just to append this character to the end of the stack. At the end, we also need to do one more check. We need to check if the stack is empty, because if there are any remaining stacks at the end, we also know that this is not a valid string. Basically, this covers all the invalid cases we discussed earlier. At the end, I'll just return this Boolean variable. Now let's actually submit the answer to see if it works. Cool. It seems that it passed all the cases. Now let's submit it. So this is the solution for this easy question. I hope you like it, and thank you for watching.